exploring quotients of polynomial functions. A rational function is defined as a function of the form f at x equals p at x over q at x, where p at x and q at x are polynomials. It's important to emphasize the fact that the numerator and denominator must be polynomial functions. Important facts about the graph that will result comes from the parts of the numerator and denominator. As you already know, let's start out with an example. Let's say f at x is equal to x minus 4 over x plus 5. So in the numerator, we'll call this p at x. The x-intercept comes from the value of x that makes the numerator equal to 0. So the x-intercept is the value of x which makes only the numerator equal to 0. In this case, x equals 4 is the 0 or x-intercept. The denominator, which of course we've referred to as q at x, is where you find the vertical asymptote. Remember, you cannot divide by 0. So the values of x which make only the denominator equal to 0 are the equations of the vertical asymptotes. So in this case, x equals negative 5 is a vertical asymptote. So we could start to make a graph and we're going to put an x-intercept at 4 and we're going to put a vertical asymptote at negative 5. So let's put a vertical asymptote at -5. And we have a x-intercept at 4. But what does the rest of the graph look like? Well, we could determine the y-intercept. So the y-intercept, we set x equal to 0. So when we do that, f at 0 equals 0 minus 4 over 0 plus 5, which equals -4/5, which of course, probably for the sake of putting it on a graph, negative 0.8. So that would be probably right in about, there. Looking at this graph, we could certainly turn this into a factor table of sorts, but I think for the purposes, the rest of this graph is going to kind of look like this. And over here, it's going to look like this. Now, I made mention of the idea of a factor table. What we could do is, I'll show you how this would just kind of look. The key points on this graph are the vertical asymptote and the x-intercept. So making a table, and putting the factors or the parts of the function in the table. And we could do x is less than -5. We could do -5 to 4. And we could do x is greater than 4. Now, when x is less than -5, obviously that's negative. That's going to be negative. So what we're doing is we're dividing a negative by a negative, so that would be positive. So certainly that kind of gels with the fact here that the y values are positive. Between -5 and 4, if you add 5 on, you get a positive, but if you subtract 4, you're going to get a negative. So a negative divided by a positive is a negative. As you can see on that interval from -5 to 4, the y values of all the points here are negative. And when x is greater than 4, you add on 5, that's positive. You subtract 4, that's positive, so the y value will be positive, as is the case right here.